Hi, this is lesson E2 in using JASP to understand statistics. And today I'm talking very briefly about doing a chi-square analysis. How is this done? An example from Graviter and Wallnow textbook basically features a study by Bob Cialdini and some classmates that I had in graduate school that actually worked on this particular study, where they littered a parking garage with either just a little bit of litter, like 0 or 1 handbills thrown on the floor, 2 or 4 handbills, or 8 or 10 handbills thrown on the floor. So what they did was they went to various cars, put these handbills on the various cars, manipulated the amount of litter that was existing, and then looked to see whether or not that would have an effect on the littering behavior of those who were returning to their cars, finding the handbill. And the idea was that if littering was viewed as normative, that is, everyone does it because you see 8 or 10 other handbills thrown about on the floor, you're more likely to pick up the handbill yourself and just throw it on the floor to litter. So we're looking at basically a relationship between two variables, but they're not continuous. They're viewed as dichotomous or categorical. The dichotomy is the behavior was that we saw from the person returning to their car was either to litter or to not litter. And that was going to be based upon the amount of existing litter, which was in one of these 3 categories. In order to analyze this type of data via the computer, we basically need to take these numbers and put them into rows in our computer setup. So this up here on the top, we're going to name our variables littering behavior. That's the variable over here. Existing litter, which is the variable that starts off over here. And then we're going to put in the frequency, that is the count, the number of people who were observed littering. And so you end up getting these rows that are showing you the 3 levels of existing litter, 1, 2, and 3, and then repeating 1, 2, and 3. The first 1, 2, and 3 exist for when the person littered. That's 1. And then the second 1, 2, and 3 exist for the not littering condition. You end up basically with 6 cells here, and we need a row representing each cell. We need for one column to represent the number of people that were doing the littering, and the other 2 columns represent, which one of the cells that we viewed them in, and then we can look to see if there's a relationship between the amount of littering behavior observed and the amount of existing litter. Okay, so let's move on and show you how this works in JASP. What we're going to do is we're going to open up a new JASP file, and then I need to plug that information that I had over here. So I'm just going to start with putting in my 1, 1, 1, 2, 2, 2, then 1, 2, 3, go back and get that 2, and 1, 2, 3 for column 3, 17, 28, 49, 102, 91, and 71. Okay, I don't need that anymore. I need to go ahead and name these. So I'm going to put this as littering. So I'm going to call it lit behavior. And I'm going to say 1 is littering, and 2 is not littering. And I'm going to make this into a nominal variable. Okay, I'm done with that. Go to column 2. In column 2, I'm going to name this exist litter. And the first one was 0 to 1. The next one was 2 to 4. And the last one was 8 to 10. Click someplace and then go over to the third one. Oops, wait. And let's make this a nominal variable. Finally, for the third one, I'm going to call this frequency. So it's the number of people that I have in each cell. Okay. And then close the variable window. I'm all set up. And you can see that I have my original numbers that I put in, but I also have the labels, so I can look at the data that way. We're now going to go to analyses, and we're going to use a new piece of information over here, which is frequencies. And we're going to go over here to contingency tables. So you're not going to see it listed as chi-square test. It's going to be contingency tables. And for the rows, we're going to put in littering behavior. Then we're going for the columns, existing litter. And it already does, oh, and then for counts, I was going to say it already does the chi-square test, and it does, but there's no relationship. But that's because it doesn't know what the counts are yet. So if I take frequencies and put it in as counts, now I get my chi-square test. It's 22.43. It has 2 degrees of freedom, and it is statistically significant. So this, as soon as you get in, you get the chi-square test result. It is useful to look and see what the expected counts were. Now, the expected counts is what's expected by chance. So this is key in interpreting the contingency table and the results of the chi-square. If you get a statistically significant result, it means that the results do not fit what was expected by chance, but is actually a relationship outside of chance or beyond chance. And so the way to look at the responses is to note that it looks as though the people who littered were doing more of that than what was expected by chance if there was 8 to 10 pieces of litter. They were doing just very close to what was expected by chance if there was 2 to 4 pieces of litter. And they were acting less than what was expected by chance if there was hardly any litter. If there was this 0 to 1, that should have been 0 to 1 instead of 1 to 1. But that's okay. I'm not going to go back and change that right now. That really is your story. They were littering more if there was more litter, existing litter, than there was if there was only a little bit of litter. You can see the same thing in terms of them not littering, because they were not littering more than what was expected by chance if there was only a little bit of litter, and less so than what was expected by chance if there was 8 to 10 pieces of litter. It's also useful to look at percentages. I think the row percentages here would be useful. And so we basically see, if we do the row percentages, that if there was a lot of litter on the ground, then 52% of the time the participants littered. But if there was only a little bit of litter on the ground, then they only littered 18% of the time. And again, that right there tells your story. And that's a chi-square test. That's it. That's the chi-square test of independence, which is found in what many researchers do all the time, which is called contingency tables. And I hope that helps. We'll see you next time.